Good morning, everybody. Hope you had a nice dinner yesterday, a good night's sleep, and enjoyed the keynote this morning, and had already a lot of coffee. And you're ready for starting with Jupyter in education. So we have our first talk today with Pierre Olivier Valle.
Yes.
He's going to talk about Jupyter notebooks. For education. And he actually worked together on this with Cécile Hardebol and Patrick Yerman.
Exactly.
And let the games begin.
Okay, thank you. So let's start. Welcome. Thank you for having me speak here. I'm quite happy. We had an initial plan to spoil you with a very nice and knowledgeable speaker about computational thinking, my colleague and pedagogical tool specialist Cécile, but she could not make it today, so I'll do my best, and please bear with me. I'm more of a technical person, but still, let's do it. Today I'm going to present you a couple of things. First, how computational thinking and notebooks can work together. Then I'll move on to the Jupyter Hub installation we did at EPFL, and I'll finish with explaining how we extended our Jupyter Hub installation by connecting it to our LMS, which is a Moodle. So maybe, for those who don't know, EPFL is a STEM university. STEM stands for scientific, technical, engineering, and mathematics university. So let's go. So what is computational thinking? From this diagram, you can see that it's made of two main components. One is the multiple representation of a concept. So for every concept we try to teach students, we try to represent it with as many representations as possible, being code, text, rich text, and sound diagrams, whatever fits the purpose. And we try to use all the channels connecting to the brain of the learner. So that's why we use multiple representation in computational thinking. The other important part is the bottom part of the diagram. It's an iterative loop of real, eval, print that makes the learner really active in the learning process. So this is how you could see a representation of the computational thinking in the engineering world. On the left, you have a traditional way of designing a part. On the right, it's parts that have been designed by generative AI, which means that over several iterations of calculations, the designer guided the tool to design the most efficient part for the purpose. So that's what we are trying to do with computational thinking, and why it's been introduced across all the curriculums in the school. Notebooks are, as you might probably know because you use notebooks, they are a good fit for all the, because they have all the features that I presented you previously on the computational thinking. They can incorporate, embed several types of representations of a concept, like images, code, and by allowing students to run code and modify it to run it again, the iterative loop is also present in the notebooks. So they are a really good fit for computational thinking. And we try to promote notebooks as much as we could. And for that, we use an approach that's been proven to work well in the past for the project. And this approach is to give technical support on one side, pedagogical support to the teachers on the other side, and also help with and promote and help funding new work by sponsoring the teachers and teaching assistant to work on notebooks. For the pedagogical support, we do trainings, 2 to 4 trainings a week, a year for teaching assistants and teachers, and we also have community events. So we try to build a community so that teachers feel confident with all those different level of support to make the leap and develop notebooks, even if they are not computer science teachers. So it's been pushed all over the different curriculums we have at EPFL. So not only computer science, and even architecture, life science. We all support them at the same level. And this has really proven to be effective, since we already have more than 30 Git repositories with cross resources available. When guiding teachers toward the usage of notebooks in their course, we have identified 4 main scenarios for which notebooks really apply, and those scenarios are really different in the sense that from left to right you can see that on the left it's mostly teachers that are using the notebook in the classroom during the course during the class to present a demonstration, and going right we have more involvement of the student in the notebook. So those are the 4 different types of notebooks: demonstration, interactive textbooks, tutorials, and all the way to labs that are fully data-driven investigation, which means the students are free to work on the data the way they want with the notebook. On top of that, we have identified a specific use case, which is assignment, which can take the form of exercise notebook or lab notebooks. But what is really important for us for the assignments in the notebooks is to provide good feedback to the student. And grading is also something that is important, especially auto-grading. So now I'll be talking more in details about the way the JupyterHub platform we have at EPFL has been deployed. So the project started in 2018. In 2019, I started working on the project on the technical side to make the JupyterHub run. In 2020, it was officially launched for the spring semester, and then on the subsequent summers, the platform has been through various updates. And right now, that's the number of users we have on the system. We are currently at more than 11,000 users, and we can see that every semester the step of new users is getting steeper. So that's a good sign. Back in 2019, when we designed the JupyterHub for EPFL, we had several design goals. The main one was to build it for education. There's several needs for having a Jupyter Hub. One being education, other is being data science, research, and high-performance computing. And we clearly decided to just focus on education and let other projects that we have also at EPFL deal with the high-performance computing and research. So we built it specifically for education, which means that we wanted to make it very simple, as straightforward as possible for the users to use it. We wanted a system that could really start fast, that could handle classes of 200 students logging in at the same time. And we wanted to provide fully functional Python and R environment so that they could work straight away. Another key goal was to have a solid base. So as I showed you previously, every summer we try to update the complete stack from Python, from the OS to Python to JupyterLab. And during the summer, we try to involve the teachers in making sure that everything is still working and that everything will be ready for the next semester. So we try to provide an up-to-date stack every year and one that has been tested. Of course, we allow users to extend their environment so that they can test specific things and are not limited to what is available on the Jupyter Hub. And recently, we also added specific environment for machine learning, computational chemistry, and very specific environment. The third design goal was to make it part of EPFL ecosystem. So we had a very strong focus on integrated Jupyter Hub with the learning platforms we have. The management system, Moodle, and other learning platform like OpenEdX. We wanted to make it very easy for the users to authenticate. This has, and I'm not the first to say it here in the conference, easy authentication is the key to have as much user as you can, that to really lower the barrier. So, of course, they don't need any specific user account. They use their regular institutional account. And the last part, it's about reusing the practices and skills that were already in place in the team. So we are managing all the services in the team, and for this new Jupyter platform that was put in place, we wanted to reuse the hosting partner we have, which is Switch, which means all the data of our users is controlled and hosted in Switzerland. And we wanted to also reuse the same tools for deployment and management that we were using in the team. One thing that is important is that back in 2019, we had no Kubernetes and Docker knowledge available in the team. Plus, our hosting partner was not really ready for Kubernetes. So that's a reason of that's the main reason of the way the Jupyter Hub has been deployed at EPFL, and you'll see why in a moment. So here's a quick diagram of our Jupyter Hub and how it's been installed within the EPFL ecosystem. So all the red boxes are institutional services that we wanted to connect to. So that means that users can come from Moodle OpenEdX using LTI connection. They also can come to the Jupyter Hub using standard web-based authentication, which in turn uses our institutional authentication provider. We also use Git hosting platform that we have at EPFL for sharing the notebooks using NB Git pull links. So at the center is the Jupyter Hub as we deploy it. So you can see there's 3 layers. Top layer is the front-end part, which is the hub. Then the middle layer is backend servers that are providing CPUs and RAM to run the user containers. And the bottom part is the file server that that takes care of the persistency of the user data. So in practice, what did we have to do to deploy this Jupyter Hub? As usual, when you deploy, when you make a Jupyter Hub installation, you need to design 2 key components to make it fit to your environment. So the first is the authenticator. That was pretty simple. We designed a specific authenticator just to use our institutional authentication mechanism. So that was easy. Then for the spawner, which is the key component that launches the user container from the hub. I was not able to use Docker container at the time, so I started in 2019 using systemd spawner, which is available on GitHub, and I realized that by tweaking it a bit and changing it a bit, I was able to make it a systemd remote spawner. If I just go back to the previous slide, you see that the Jupyter Hub layer at the top is sending the user, is spawning the user on the other servers that are the backend servers. So that's why it needed to work remotely. So that's the main component of the systemd remote spawner. It just launches systemd containers on a remote server. And to do that, we had to implement a cluster management that is able to start and stop servers as needed to cope with the load, and also to indicate to the hub to which server the user should be sent. If a server has more free memory, then he'll get the next user. That's basically how it works. So this is an example of just a regular standard morning at EPFL for the Jupyter Hub service. At the graphic at the top, you can see the users coming. That morning we had 2 courses running more or less at the same time. One started around 9:30, another one around 10:30. And on the bottom left, you can see the number of nodes that were activated in the cluster. So as users come in and log in, the cluster management system is able to activate more and more servers to give them to give room for the new users. So we are not using Docker containers, but we are using different kind of container. Let's say it's a craft with love and designed by myself. So as explained, the spawner launches the systemd unit that in turn launches a bubble wrap container that in turn launches JupyterLab for the user. So it's a series of embedded boxes that makes a secure and controlled container to execute the JupyterLab environment for the user. That's how it works. And it's not perfect. I'm not recommending you should use that instead of Docker containers. But the thing is that it works. It's been working for the last 4 years, and it's pretty fast in the sense that in 10 seconds, the container is generated and started for the user. One key component was to integrate our Jupyter Hub platform into the usual and typical workflow for the teachers and students. We know that they use Moodle for assignments. They use it. The teachers and students are all using it, and they like it. So we did not want it to make a different kind of workflow where Jupyter could fit. So we decided to fit Jupyter inside the current and well-known workflow for the teachers. So we developed a couple of Moodle plugins that makes available notebooks as assignments for teachers and students. So this is the usual workflow that teachers and students use for whatever kind of assignment, and we made it work for Jupyter notebooks. So how does it work? Technically, as I said, we have 2 plugins on the Moodle side that make Moodle aware that there are Jupyter notebooks assignments. Whenever a teacher creates a notebook assignment, he is able to select from his Jupyter workspace a folder that contains the assignment. So he works on his Jupyter workspace, builds and prepares the notebook that will serve as a base for the assignment, and then from Moodle, when he creates the assignment, he just has to select the folder containing his assignment, and it's automatically zipped and sent back and stored on Moodle. Then the students, they can more or less do the same. They connect to their Moodle account. They say, oh, there's a new assignment. Let's send it to, there's a new notebook assignment. They connect and send it to their Jupyter account using the same mechanism. And they work on it, and then they can, once they finish, they go back to Moodle and they say, okay, I want to submit. They select the folder in which they've been working on their Jupyter workspace, and the assignment is submitted. So we made it. We just streamlined the communication between Moodle and the file server that contains all the Jupyter workspace, and we avoid having the teachers and students to work in Jupyter, then download on the computer, and then upload to Moodle. So it's all done in one step, and it really minimizes the chances of mistakes, and it makes the process much easier. And here's the conclusion. So we saw the 3 points that I told you, and what is important is the work that we still have in progress. Right now, the next step for us is to focus and find a proper solution for grading. At the moment, we have AutoGrader and BigGrader, both available on the Jupyter platform. So we have users for both of them, and we are still not made a decision on which tool is the best, which one we should recommend. But anyway, we try to support active users, and but that's still something on the radar. We're working on that. Also, group assignment features. This is something that needs to be. We need to make sure that it works perfectly with the Moodle assignment plugins that we've developed. And that's it. Thank you.
Thank you. Do we have any questions?
You get a single instance of Jupyter Hub which caters all these 11,000 users?
Sorry?
You have a single instance of Jupyter Hub which caters all the 11,000 users?
Yes.
And the latencies are okay? Are you happy with this?
Yes. I mean, we have 11,000 plus users, but only 5,000 of them are active during the semester. In a typical day, we have between 300 and 500 students that connect. Sometimes 200 at the same time, sometimes more, sometimes less. But that's about that. And on the file server, we store only the active users. So that's the 4,000 or 5,000 that I told you. Plus, we keep a copy of the, we have what I call the freezer. The user that did not connect recently had just moved away, so they are not part of the backup, and the process is easier for the system for them. And after a year, we push them to the graveyard.
Can I ask one more question?
Yes, yes, I will.
All your users have like a single node workloads? I mean, like all the JupyterLab instances are like launching only on one node at a time?
No, that's, let's go back here. So you see we have 15 nodes on the second line. This is the backend server that are running the containers. So we have from 1 to 15 server active at the time. And when a user comes from on the Jupyter Hub, the Jupyter Hub asks the cluster management, where should I send this user? The cluster management has a clear view of the status of the memory on all the nodes and say, okay, let's send this one to backend 5. Then the user gets to backend 5 and stays there until it's done.
Thank you for the presentation. It was really interesting, especially we always often have some talks about the pedagogical side of Jupyter stuff, and that was really interesting to get the technical side. I'd like to know if you consider only from the start of the project to the initial launch, could you give an estimate for the number of person months needed to just make something like that happen?
So in this precise case, I joined the team in 2019, 1st of January, so that's very easy. The project was just launched. We knew that we wanted to have a Jupyter Hub instance on premise, but nothing was done. So from 1st of January till the summer, I worked at evaluating the different options, possibilities, learning the practices that we had in the team. And by the summer, I had a working prototype that was put in place for the autumn semester of 2019, but we did not announce it. We selected a bunch of teachers we are comfortable working with, and we tested it in real conditions, but with only a bunch of teachers. Then in 2020, 2020, it was launched officially, and so it was a year between the start and the effective deployment.
I think we have to prepare for the next talk. We can come. If you have still questions for the speaker,
yes, feel free to
do it
to come back.
while
Come to me. Yes.
We are preparing the next speaker. So, and another round of applause. Thank you very much.
Thank you.